All right, welcome to the last talk of day one, UGM2021. This is Illyoung Choi from CyVerse out in Arizona, and he's going to talk today about accessing iRODS in Kubernetes. And he's got 3 pieces of software because he's very prolific: Go-iRODSClient, iRODS FUSE Lite, and iRODSCSI Driver for Kubernetes itself. There you go, Illyoung.
Thank you for the introduction. Hi, I am Illyoung Choi at CyVerse. In this presentation, I will be talking about iRODS access in Kubernetes. I'm going to introduce 3 projects: Go-iRODSClient, iRODS FUSE Lite, and iRODSCSI Driver. I am working with John Hartman and Edwin Skidmore for these projects. As you all know, Kubernetes is a computing system for automating deployment, scaling, and management of containerized applications. It is a de facto standard platform for cloud-native architecture. In Kubernetes, we have 2 existing iRODS access methods available. The first method is downloading and uploading data before and after jobs. commands or Python iRODSClient can be used to transfer iRODS data to the container. This is a commonly used method as it is straightforward. However, it requires management of data transfer and local copies. The second method is mounting iRODS data in Kubernetes pods. Several iRODS file system clients, such as iRODS FUSE, WebDev, or NFS, can be used for this. This provides on-demand data access to iRODS. However, it also requires management of file system mounts. So you have to mount and unmount data. iRODS has been used in CyVerse as a storage system for community data sets and user data. We have integrated iRODS with CyVerse services. For example, CyVerse Discovery Environment is a Kubernetes-based scientific computing service. Scientists can run scientific apps in the discovery environment with community data sets or user data stored on iRODS. So far, CyVerse DE has used the first method, downloading and uploading data before and after jobs. However, we wanted to integrate iRODS with CyVerse DE more tightly using a standard Kubernetes data access interface, which is called persistent volumes for ease of data and access management. To create persistent volumes for iRODS, we had to implement a container storage interface, CSI Driver for iRODS. So our first goal is developing a CSI driver for iRODS. By implementing a CSI driver, we can extend storage support in Kubernetes. iRODS CSI driver provides access to iRODS in Kubernetes through the persistent volume. Container storage interface relies on Linux file system mount for data access. So iRODS CSI driver also has to use iRODS file system clients. There are 3 iRODS file system clients available: DevFS2 for WebDev, NFS client for NFS protocol, and iRODS FUSE. DevFS2 implements WebDev protocol. Since WebDev protocol is based on HTTP, web caches can be configured to improve read bandwidth for frequently accessed data. That is very useful for community data sets. However, it requires DevRODS setup for protocol support. NFS client also can be used However, it requires NFS roles set up for supporting NFS protocol. Also, its authentication mechanism is less secure because it relies on host authentication. iRODSFuse is an iRODS-specific file system client. The client is not currently well maintained, so it has some bugs unfixed. I'm sorry about that because I am the author of the client. However, iRODSFuse has some advantages, like it can directly communicate with iRODS server without any extra services. Also, it is customizable. So we can add more iRODS specific features to it. For example, proxy authentication. So we decided to update iRODSFuse, but re-implementing it in new programming language, Golang, and we renamed the client iRODSFuse Lite. Both iRODSCSI Driver and iRODSFuse Lite are implemented in Golang. To provide the iRODS access in iRODSCSI Driver and iRODSFuse Lite, we required an iRODS API library in Golang. We implemented one in pure Golang to improve portability. Actually, there is an existing API library, but it's less portable because it relies on iRODSC API library. We named this library Go-iRODSClient. So Go-iRODSClient is an iRODS API library written in Golang. We chose Golang for a programming language of the 3 projects. There are some reasons for this. First, it is portable. It's easy to build a binary for different systems, as Golang is already widely supported. Libraries written in pure Golang are deployed in the code level, so it doesn't cause any compatibility issues. Second, it's highly productive. It supports garbage collection, so there is no pointer-related problems. I mean, memory allocation and deallocation problems. A lot of libraries are already available, and more. It is simple as Python, but it's powerful as C. Third, Golang is the most widely used programming language in Kubernetes. So you must use Golang to learn from existing code. So iRODS is integrated with Kubernetes using 3 projects. iRODSCSI Driver receives a persistent volume request from users and controls iRODSFuse Lite for data mount, and it controls Go-iRODSClient to manage user data. And iRODSFuse Lite also uses Go-iRODSClient for iRODS data access. Here's a code example that uses Go-iRODSClient for file download. So the library can be easily installed using go-get command and imported like this. It's like Python import. Then first read the external file for login credentials and host information from YAML file, and I created a high-level file system like interface for iRODS access, and then I use the file download file API that simply downloads an iRODS data object to local disk. Of course, the library provides low-level APIs for byte range input and output, but in this example, it's not used for simplicity. Here is another example that uses a Go-iRODSClient for directory listing. In this case, I use the list function in the high-level file system-like interface, and it returns the entries. So it's very simple to use. It's very similar to Python iRODSClient APIs. Okay, let's jump to iRODSFUSE Lite. iRODSFUSE Lite mounts iRODS data in the file system. This is possible via FUSE interface. FUSE runs at the kernel level and communicates with Linux virtual file system. So file system access on the mount points are sent to FUSE and passed to iRODSFUSE Lite that implements the FUSE protocol. iRODSFUSE Lite uses bazel.org FUSE library to communicate with FUSE. iRODSFUSE Lite also uses Go-iRODSClient for iRODS access. So iRODSFUSE Lite is a kind of thin client that wraps the FUSE interface and Go-iRODSClient. Here's a quick demo. In this demo, we are going to mount an iRODS collection using the iRODSFUSE Lite. The iRODSFS is the iRODSFUSE Lite program. I gave a URL-like parameter to pass login username and iRODS host information. And now I'm giving a collection path. And the last parameter is mount point. Once it is mounted successfully, I can access the collection as if it is a local directory. I can also use tab completion because it's treated like just a directory. And I can access the data. Okay, now let's talk about iRODSCSI Driver. iRODSCSI Driver has two internal components, controller and node. Controller is responsible for processing dynamic volume provisioning requests. That request is made by Kubernetes users or other external services. When users create persistent volume claims, that is Kubernetes object, once that claim is created, then the controller creates iRODS collections and persistent volumes dynamically from the claim and then pass to a node module. The node module is responsible for processing static volume provisioning request, which means you need to pass persistent volume object and persistent volume claim object. It mounts iRODS data for persistent volumes using iRODS file system clients. We have three options. The first is iRODSFUSE Lite and DevFS2 or NFS client. Once data is mounted, Kubernetes pods can access the data via the mount points. Let's talk about the I/O performance. We compared I/O performance of three iRODS API libraries: Go-iRODSClient and Python iRODSClient and Jargon. Jargon is Java library. Jargon was the fastest, as you see here. it showed very good performance for file download. We think this is because it uses stream read. That's how IO works. Parts of data can be read as soon as they arrive in stream read. However, Go-iRODSClient and Python iRODSClient do not implement this feature, so it blocks until it receives all data requested. So it handles data I/O sequentially. Synchronously. So that's why it is slower than Jargon for file read. We plan to implement the stream read function in Go-iRODSClient as well. Also, Python iRODSClient recently implemented new parallel data transfer API. So we are going to implement it in Go-iRODSClient. Here's another I/O performance comparison between iROD file system clients. We compared DevFS2 for web dev and NFS client and iROD FUSE old version, and we compared them with iROD FUSE Lite. NFS client outperformed for download, the red one. This is because it uses Jargon for iROD data access, and it uses stream read as well. So it showed the same performance as Jargon. DevFS2 also showed good download performance. Here, the blue bar. We guess it also implements stream read, but has some overhead somewhere in the middle. We need more investigation to figure this out in more detail. iROD FUSE Lite showed good upload performance as it directly communicates with iROD server. It also showed a better I/O performance than existing iROD FUSE client. Here, we plan to improve I/O performance of iROD FUSE Lite and want to make it as fast as NFS client in the future. We already integrated these projects with CyVerse services. Go-iRODSClient is used by a new service, CyVerse Data Watch. That is a data monitoring service for data store. iRODSCSI Driver is already integrated with CyVerse discovery environment. We applied it in our test environment, but we plan to apply it in production in this fall. Okay, to conclude, if you are working on a Go project and want to access iRODS, then Go-iRODSClient is a useful library. If you want to mount iROD data on the file system, then iROD FUSE Lite is a new option that replaces a previous version of iROD FUSE. If you want to access iRODS in Kubernetes environment, then iRODSCSI Driver is the simplest option that provides iROD access. Okay, thank you for listening. The projects are open source and available on GitHub repositories in this link. Thank you. And do you have any questions about that?
I think this is great. You've got some people excited, I think. I thought it was pretty funny how you said there were some bugs in the other client, and then you said, well, that's me, and I apologize. It's pretty funny.
Yeah.
So we've got some questions about the graphs that you showed for performance. Obviously, you know, functionality is prime, and then performance is a thing we talk about later. But
Mhm.
Does the FUSE Lite client support parallel transfer for uploads? And I think you maybe did answer that, but not yet.
Oh no, the iRODSFuse Lite does not currently use a parallel upload yet, because that's because we did not implement it in
Right.
Go-iRODSClient. So we are going to add it in the future, and once it's done, then we can get better performance for data write, possibly.
Yeah. And so we are very interested in that work. Obviously, the work that we've done in the server for the multi 1247, the multi-process, no high ports, just all on 1247, I think is going to be very interesting to this type of client as well. So we're going to work hard to, get that contract, so to speak, published and documented, so that, I think in a couple hours of work, you'd probably have it squared up, and it would be really, really fast, be clean.
Mhm.
Let's see. Do you also run the iRODS server itself in Kubernetes as a Docker image?
For testing?
Maybe. This is a
yeah, for the benchmark purpose, yes, I set up iROD in the Kubernetes. Oh no, I run iROD in a separate environment.
Okay.
For benchmark, and then we are running the real iROD deployment, that is CyVerse data store, but that's not for benchmark.
Yeah, production quality, right.
Yeah, I don't think we are running them on the Kubernetes environment yet.
Okay. And then Jason's saying it's time to revisit Minio with the new Go-client API in terms of understanding, speed and throughput. If we're kind of focused on not Amazon in the sky networking, if we get that performance for local cloud. And say it again. Oh, and the S3 interface as well.
Yeah,
that's right. Let's see. And then Mike says that's what Gen 3 is all about. There's a John Jacquet at BioTeam had done that also, I think. So there's some precedence for this. This is good. And then a couple more people talking about containers in the production, but not in Kubernetes. So this is great. What's been the biggest snag, if you've hit anything in kind of doing this in Go? Has there been any surprises that you did not see coming that were a little bit trickier than you thought?
The trickiest part was the understanding the iROD protocol, because there was no detailed documentation about that. So I implemented the protocol from scratch by reverse engineering the Python iROD client.
So you looked at Python to do it. Yeah, that's interesting.
Yes. Yeah. So that's why Go-iRODSClient is very it has very similar structure as Python iRODSClient, because I reverse engineered it.
Right.
Yeah.
Very good. Let's see, a couple more things happening over here. So how would you, this is from John Constable, he says, how would Illyoung expect the assorted clients to deal with greater than 65,000 files in a collection? So if you had a lot of data objects in the same collection, would it, have you tested that? Have you given it a big load?
For the iRODSFuse Lite?
I think so.
In that case, I think the Go-iRODSClient will not have any problem with that, because it already supports pagination. But iRODSFuse Lite may have problem. That's the same for the local file system as well. If you have, millions of files in a directory, then when you type ls, it will take few minutes probably to list all the entries. It will be the same for the iRODSFuse Lite. So for that number of collection, we don't suggest using iRODSFuse Lite, but there is an option if you want to access the data objects selectively. Like, can you see my screen anyway?
I think you just exited out, so you're not sure.
Yeah, I think something happened to my screen. let me share another page. Okay, it's the last page. So, so there's a custom path mapping feature newly introduced to iRODS FUSE Lite. So if you selectively access some files in a collection, like just, I mean, 100 out of millions, then you can make a custom path mapping so that only that data objects are mounted on the file system. So using that, you can map, I mean, collections or data objects from different paths as well onto this single mount point. So that is very useful for mounting reference data sets and your inputs and output data output directory in a single mount. I mean, that's pretty useful function. So if you are planning to access just a few files out of millions, then yeah, you can use that option.
Right, but that needs to be maintained by each person, or is that maintained at the system level for everybody?
When you mount, I mean, using iRODSFS, you can give that mapping through the configuration file.
For user, if they're mounting it for themselves.
Yeah, actually the mapping is a JSON file, so you can pass that file when you launch the iRODS FUSE Lite.
Got it. That makes sense.
And CSI Driver as well. So that's how CyVerse DE integrates the CSI Driver, because we need to map multiple input collections and data objects and output directory as well. So we use just a single iRODS FUSE Lite process to handle all of them.
And then it shows up in DE that way. Yeah.
Yeah.
Very good. I think that's all the questions from the Slack channel. I appreciate it. This is exciting. We've got new clients. We have to add some more things to the clients page at iRODS.org. That's right. Appreciate it. Thank you.
Thank you.